The ocean's surface often appears calm and inviting, but lurking beneath are some of the most formidable threats known to humankind. Imagine waves that can reach the height of skyscrapers or currents so strong they can drag even the largest vessels into their depths. Today, we bring you face to face with these incredible forces, the most dangerous natural phenomena in the ocean. Maelstrom. A maelstrom is a massive whirlpool formed when two opposing currents collide, creating a dangerous circular vortex. Imagine two strong rivers meeting head-on, twisting into a powerful swirl. Even the fearless Vikings were terrified of them, believing these whirling waters could swallow entire ships. They weren't entirely wrong. Without modern technology, large ships could easily be pulled under by its force. Today, modern ships are generally strong enough to withstand these currents. However, these whirlpools can still be dangerous. For example, a cruise ship caught in one might not sink, but passengers would experience intense rocking from side to side. One of the most famous maelstroms is the Moskstraumen off the coast of Norway. This natural wonder can create waves over 40 feet high and currents reaching speeds of up to 20 miles per hour. Such whirlpools can also act like underwater black holes. These oceanic black holes are so powerful that anything caught in them has little chance of escaping. Spanning up to 93 miles in diameter, their invisible boundaries make them even more treacherous. If caught in one, you might not realize it until it's too late. Cross sea. Imagine standing on the shore and seeing waves forming a checkerboard pattern on the ocean surface. These square waves are not just beautiful, they're incredibly dangerous. This phenomenon occurs when two wave patterns intersect at oblique angles, usually when different weather systems meet. This creates a grid-like pattern of waves crisscrossing each other. While it looks amazing from the shore, it can be treacherous for anyone in the water. Common in shallow parts of the ocean, this pattern can happen in many coastal areas worldwide, such as France and certain beaches in Tel Aviv. The danger lies in its unpredictability. The waves can be very tall, sometimes up to 10 feet, and the intersecting patterns create powerful currents beneath the surface. These currents can be difficult to navigate, even for experienced swimmers and boaters. The waves can change direction suddenly, making it easy to get caught off guard. Strong ocean currents create the cross sea, pushing and pulling in different directions. For swimmers, this means a high risk of being pulled under or swept out to sea. For boats, especially smaller ones, the rough and unpredictable waves can capsize them in an instant. Just a quick moment before we unveil the rest. If you're new here, consider subscribing to this channel. Stay up to date and never miss out on the latest insights. Red tides. Imagine heading to the beach eager for a swim, only to find the water has turned a startling shade of red. This eerie transformation is caused by a red tide. But what exactly is a red tide and why is it so dangerous? A red tide occurs when certain types of microscopic algae, specifically dinoflagellates, multiply rapidly. This phenomenon, known as an algal bloom, can turn the water red, brown, or even green. While most algae are harmless and beneficial, the algae responsible for red tides produce powerful toxins. These toxins can have severe impacts on marine life and human health. Marine animals like fish, sea turtles, and birds are particularly vulnerable, often experiencing massive die-offs. The sight of thousands of dead fish washed up on shore is a tragic reminder of the power of these tiny organisms. For humans, these tides pose serious health risks, especially for those with respiratory issues. When the wind blows the toxic algae towards the shore, the toxins can become airborne, causing symptoms like coughing, sneezing, and throat irritation. People with asthma or other respiratory conditions may experience more severe reactions. Swimming in affected waters is also dangerous. Direct contact with the toxins can cause skin irritation, rashes, and burning eyes. Ingesting contaminated shellfish, such as clams or oysters, can lead to severe food poisoning, with symptoms ranging from nausea and vomiting to neurological problems. Tidal bore. A tidal bore is a remarkable phenomenon that occurs when the incoming tide forms a wave or series of waves, traveling up a river or narrow bay against the river's current. Imagine a wall of water pushing upstream, creating a sudden rise in water level. This is the essence of a tidal bore. Tidal bores require specific conditions: a fairly shallow river with a narrow outlet to the sea, and a significant tidal range, usually at least 20 feet. These conditions create the perfect environment for a tidal bore to form. One of the most famous examples is the Pororoca on the Amazon River in Brazil. This powerful bore can travel over 400 miles upstream, with waves reaching up to 12 feet. The Pororoca is known for its strength and the roaring sound it makes long before the wave is seen. Another well-known case occurs in the Qiantang River in China, known as the Silver Dragon, which can produce waves up to 30 feet high. Spectators gather annually to witness this incredible event despite the risks involved. Tidal bores are dangerous because the sudden surge of water can change the river's conditions in minutes. The force of the tide creates severe turbulence, powerful currents, and whirlpools hazardous to swimmers, boaters, and anyone near the water's edge. For boats, especially smaller ones, this phenomenon can be devastating, capsizing vessels, sweeping them upstream, or smashing them against the riverbanks. Even large ships can struggle against a strong tidal bore. For those on shore, these surges can be perilous. The rapid rise in water levels can flood low-lying areas, sweeping away anything or anyone in its path. Seafoam. Seafoam is a fascinating sight that can turn a typical beach day into a memorable experience. Imagine walking along the shore and seeing the waves create thick, frothy foam that blankets the water's surface and sometimes the beach itself. While it might look fun and harmless, seafoam can sometimes pose serious risks. It forms when ocean water, containing dissolved salts, proteins, fats, dead algae, and other organic and inorganic matter, gets agitated by wind and waves. When these components mix, foam is created, similar to how soap bubbles form in your bathtub. In most cases, seafoam is harmless and can even be quite beautiful, creating a thick white blanket along the shoreline. However, there are situations where seafoam can be dangerous. One primary cause of hazardous seafoam is algal blooms, particularly harmful algal blooms, also known as red tides. When large algal blooms decay, they release significant amounts of organic matter into the water, forming dense sea foam. The problem arises when these algae are toxic. Some types produce harmful toxins that can become concentrated in the sea foam. When the foam bubbles pop, these toxins can be released into the air, posing health risks to humans and animals. People who come into contact with toxic sea foam may experience skin irritation, rashes, and eye discomfort. Inhaling airborne toxins can cause respiratory issues such as coughing, wheezing, and throat irritation, especially concerning for individuals with pre-existing respiratory conditions like asthma. One notable incident occurred in 2007 in New South Wales, Australia, where massive amounts of sea foam covered beaches and coastal towns. While it looked like a winter wonderland, the foam was actually the result of decaying algal blooms and contained harmful substances. Authorities had to warn residents and tourists to avoid contact with the foam due to potential health hazards. Tsunami. A tsunami is a series of enormous ocean waves caused by underwater disturbances like earthquakes, volcanic eruptions, or landslides. These waves travel across the ocean at incredible speeds, sometimes up to 500 miles per hour. As they approach the shore, their height increases dramatically, turning them into towering walls of water. Imagine enjoying a peaceful day at the seaside when the ground begins to shake beneath your feet. This could be an earthquake. Next, you notice the water rapidly retreating from the beach, exposing the ocean floor. This is a crucial warning sign that a massive wave might be imminent. If you see this, you have only a few minutes to act. The best course of action is to immediately move to higher ground. A tsunami doesn't always arrive with dramatic waves crashing against the shore. Sometimes it comes as a rapidly rising tide, inundating coastal areas with little warning. The initial wave might not be the largest. Often, the most powerful waves come later. The impact can be devastating. The immense force of the water can demolish buildings, sweep away vehicles, and uproot trees. It can also cause severe flooding, contaminating freshwater supplies and damaging infrastructure. One of the most catastrophic events occurred on December 26, 2004, triggered by a massive undersea earthquake off the coast of Sumatra, Indonesia, affecting 14 countries and claiming over 230,000 lives. When such a wave is approaching, you might notice unusual behaviors in the ocean, such as seawater bubbling, swirling, and creating strange patterns, signs of severe underwater turbulence. To protect against tsunamis, many coastal areas have implemented warning systems. These systems use seismographs and ocean buoys to detect undersea earthquakes and monitor changes in sea level. When a potential tsunami is detected, alerts are sent out via sirens, text messages, and emergency broadcasts, giving people as much time as possible to evacuate. Submarine volcanoes. When we think of volcanoes, we often picture towering mountains spewing lava and ash into the sky. But many volcanoes are hidden beneath the ocean's surface. These submarine volcanoes can be just as powerful and dangerous as their land-based counterparts. Underwater volcanoes form similarly to those on land, Tectonic plate movements cause magma from the Earth's mantle to push through the ocean floor, leading to eruptions that release lava, ash, and gases into the surrounding water. In shallow waters, these volcanoes can create dramatic displays, blasting debris and steam high above the surface. These eruptions are incredibly powerful, with explosions propelling water and volcanic material hundreds of feet into the air. In deeper waters, the immense pressure suppresses explosive eruptions, but lava still flows out and spreads across the seafloor. When this lava cools rapidly, it shatters into fragments, creating vast fields of volcanic rubble and sand. These underwater landscapes can be stunning, but also pose challenges for marine navigation and research. Submarine volcanoes pose significant dangers. The gases they release, particularly carbon dioxide and sulfur dioxide, can create toxic plumes harmful to marine life and human health if they reach the surface. Another danger is the formation of hydrothermal vents, which release superheated water and minerals into the ocean. These vents create extreme conditions deadly to most marine organisms, but support unique ecosystems with specialized creatures. One of the most hazardous aspects of these underwater eruptions is their ability to create tsunamis. For example, the 1883 eruption of Krakatoa, which was partly submarine, caused a massive tsunami that devastated nearby coastlines and killed tens of thousands of people. Marine quicksand. When we think of quicksand, we often imagine it on dry land. However, quicksand can also form in the ocean, particularly in coastal areas with a mix of sand, silt, and clay. This phenomenon, known as marine quicksand, poses unique dangers to both humans and animals. Marine quicksand forms in shallow waters where fine sediments accumulate. These sediments can become waterlogged and lose their solid structure, creating a thick, soupy mixture. When disturbed, this mixture behaves like a liquid, making it easy to sink into, but difficult to escape from. Imagine stepping into what appears to be solid sand, only to find yourself sinking rapidly. One of the main dangers is its deceptive appearance. To the untrained eye, it may look like any other part of the beach or seabed. However, the seemingly firm surface can quickly turn into a trap, making it particularly hazardous for beachgoers, swimmers, and animals. If you find yourself trapped in marine quicksand, it's important to stay calm. Panicking and struggling can make you sink deeper. Instead, try to lean back and spread your weight as much as possible. Underwater fireballs. Underwater fireballs, also known as methane seeps or methane eruptions, are a fascinating and dangerous phenomenon in the ocean depths. These fireballs form when large amounts of methane gas are suddenly released from the seabed, creating explosive bursts of energy underwater. Methane is highly flammable, and its release in significant quantities can create spectacular and hazardous events. Imagine an immense bubble of gas rising from the ocean floor, expanding rapidly as it ascends. When this bubble reaches the surface and contacts the air, it can ignite, causing a dramatic explosion or fireball. One primary source of this phenomenon is methane hydrate deposits. These crystalline structures trap methane gas within ice and are found in cold, deep ocean environments and under permafrost. Changes in temperature or pressure, such as those from underwater landslides or drilling, can destabilize these deposits, releasing the trapped gas. The release of methane has significant environmental impacts. Methane is a potent greenhouse gas, much more effective at trapping heat than carbon dioxide. Large-scale releases contribute to global warming and climate change. Additionally, the sudden release of methane can create dangerous conditions for marine life and human activities. For ships and submarines, methane seeps pose a serious threat. The rapid gas release can decrease water density, reducing buoyancy and causing vessels to sink. This phenomenon, known as methane-induced buoyancy loss, has been linked to shipwrecks in areas with high methane seep activity. Underwater fireballs also present risks to offshore drilling operations. Drilling into methane hydrate deposits can trigger sudden gas releases, leading to blowouts and explosions. These incidents can cause significant damage to equipment, endanger workers, and result in environmental disasters. Rogue waves. Rogue waves, also known as freak waves or monster waves, are massive and unexpected ocean waves that can appear suddenly without warning. These waves are often much larger than the surrounding waves, reaching heights of up to 100 feet. Imagine being at sea and seeing a wall of water as tall as a 10-story building rushing towards you. That's the terrifying power of a rogue wave. Unlike tsunamis caused by underwater earthquakes or volcanic eruptions, rogue waves are usually generated by complex interactions of wind, currents, and waves. They can occur in any ocean at any time, making them particularly dangerous for ships and offshore structures. One of their key characteristics is their unpredictability. While scientists have theories about how they form, predicting their exact occurrence remains challenging. They can form in deep waters, far from shore, where ships often feel safe. This sudden appearance in seemingly calm conditions makes them especially hazardous. They have been responsible for numerous maritime disasters. They can strike with incredible force, smashing windows, damaging equipment, and even capsizing large vessels. One famous incident occurred in 1978 when the cargo ship MS München disappeared in the North Atlantic. The ship sent a distress signal, but when rescue teams arrived, they found only debris. It's widely believed that a rogue wave was the cause of the tragedy.